This is an exciting one for me because it's really, really important for what we're going to be doing this year, but it's also important. You're going to be using the concepts from this unit next year in geometry a lot, because geometry has a lot to do with lines. We make shapes out of lines. You're going to be using it a ton in Algebra 2. And then we're actually messing around with some linear relationships in pre-calculus right now as well. In our last homework assignment in pre-calculus, we were writing equations of lines. I'm going to show you guys in next week, actually, it'll be the week after next. I'm going to show you a problem that appeared on my pre-calculus students' homework a couple nights ago. So today's our first day. We're going to dive in and start looking at not lines today. We're going to be looking at a different situation. Let's make sure we get our first and last name on our packets. Could you guys please write your first and last name? And this is period 5. And today we're going to be tackling just this first lesson here, 2.1.1, and today is the 9th, so we'll go 10-9. All right, let's dive into it here, folks. Well, you know what? I'm getting ahead of myself. You guys can turn the page if you want. I want to talk about our learning targets first. Our goal for today is we're going to be looking at different representations of a linear function. Linear functions are things that when we graph them, it makes a line. We're going to learn some more definitions for that same thing here as we go through the unit. When we say representations, there are 4 main representations that we will deal with in this class. Those representations are situation, table, equation, and graph. Today we are going to be focusing on situations, tables, and equations. We will not be graphing these things today. And before you leave today, I want you to be able to look at a situation that involves linear growth. I need you to be able to turn that situation into a table. And then also before you leave today, I want you to be able to look at either a situation or a table and turn that into an equation. And there are going to be 2 main concepts that you're going to need for this, and I'm going to write these down here. I'd encourage you to copy them down here as well. Growth and starting value. Growth and starting value are going to be the 2 big concepts. I want you to be thinking about those concepts and trying to make a connection between situations, tables, and equations today. So, okay, now let's get into this. Some questions that I'd like you to keep in mind. We're going to be talking about these tile patterns. So one of the big questions is, how can you see growth in the tile pattern? Second question, what is the starting value for a tile pattern? And then how can we make a connection between that tile pattern and an equation or a table? So I'd like you to start by using your pattern recognition skills. This is a series of figures, and each one represents a tile pattern. So if you imagine each one of these little squares that's darkened in here is a tile. What I would like you to do is tell me, first of all, figure out what's going on in this pattern, and then make a sketch for me of figure 4 and figure 0. So what would be the next pattern, and what would be the pattern that came before this one? So have a look at that. If it helps you to, one thing that helps me to do this when I'm working these problems is for each of my new figures to go through and color in the new tiles. For example, from figure 1 to figure 2, this tile was new, and these 2 tiles up here were new tiles. And then when I went on to figure 3, this was a new tile, and these 2 up here were new tiles. So if it helps you to color in those new tiles to figure out what's going on in your pattern, go ahead and do that. Go ahead and make me a drawing of what figure 4 and figure 0 would look like. Take a moment, let you do that. So if you haven't finished drawing figure 0 and figure 4 yet, that's okay. Just look up here for a moment. Let's answer this next question. If I were to ask you to describe how does the pattern grow? So if I said, here's figure 1, you tell me, what do I do to that to come up with my next figure? What would you tell me? Does anybody want to try and put that in words for me? How does the pattern grow? Can I get a volunteer? Okay, yeah, thank you. Okay, so it grows by 1 block. Where does it grow by 1 block? On which side? So on the left, we're going to grow it by 1 block. Oh, thank you very much. And on the right-hand side, we're going to grow by 2 blocks. I love that. Is that consistent over here? It grows by 1 block, and then it grows by 2 blocks. So if I were going to draw the new one for figure 4, I could draw exactly what I've got here. I do need to move it down to fit it in. 1, 2, 3, 4, 5. There were 6 across the bottom and 6 going up the side. So this is what figure 3 looked like. So you're saying to make my new one, I would add 1 more block over here and 2 more blocks over here? Awesome. Works for me. And then going backwards, then we should be able to just do the opposite of that, right? So if I wanted to work backwards, I'm going to remove 2 blocks from the right and remove 2 blocks from the left. So if I wanted to work backwards from this, I'm going to remove these 2 blocks, and I'm going to remove this 1 block, and I'm just going to have those 4 left over in the center. Is that what you guys had for figure 4 and figure 1? Or, sorry, figure 0? All right. So how does it grow? Go ahead and write some words down here. We could say we add 1 block on the left and 2 on the right. Now, when we deal with these, we're going to be looking for visual patterns for where we add these new tiles on. And it seems like you guys nailed it in this first one. But in general, really the thing we're interested in is how many tiles there are altogether. So if I asked you for this pattern, how is the number of tiles changing? How many tiles are we adding on each time? We're adding 3 on altogether, the 1 on the left and the 2 on the right. So if I were to ask you for the growth for this, I would say the growth was plus 3 tiles. So when we're talking about how much something grows, we're talking about how many does it change by. All right, let's talk about the starting value. The starting value is always going to be when we're talking about a value of 0. So in this case, it'd be figure 0. Grab a packet from the back there before you sit down, please. So for figure 0, how many tiles are we starting with? How many tiles in figure 0 here? Looks like 4. So my starting value is going to be 4 for this particular scenario. Starting value is 4. Okay, they want us to make a table on an equation, so let's go ahead and make a table here. So what do we know? I know that, well, for figure 0, there's 4 tiles. So you do some counting and figure out for me how many tiles are there in figure 1, figure 2, figure 3, figure 4, figure 5. You could count them, or you could try and use a pattern to make this a little simpler for yourself. I'll let you decide which way you want to go on that. One, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is there a quicker way that you found than just counting each time? What could I do that would be much faster? Help me out. Yes, Winter. We could just add 3 each time. We know it's going to grow by 3 tiles each time, so we don't need to sit and count every single one of them. So we could just add 3. So we could go plus 3 would be 13. We're going to add another 3 to get to 16. We don't even have figure 5 in front of us, but we know by the pattern that we've been given so far that if we did have a figure 5 and we did count up all the tiles, we would have plus 3. Another 3 would get us to 19. Okay, so we've got our situation. Our situation tells us about the growth and the starting value, and now we've got our table. Really quickly, where are you seeing the starting value in the table? Well, we always see the starting value at when x is 0. That's always going to be our start. And are you seeing a connection with the growth in the table? If you figured out that shortcut that we just discussed, the fact that each time we move forward, we're doing plus 3 and plus 3 and plus 3, that's where our growth shows up in the table. All right, the last piece that we got to put into this is the equation. So we're going to write an equation, and our equation is going to be y equals, and I'm going to give you the format of the equation because I think some of you have seen this before. It's going to be y equals something x plus something. Does anybody know what number would go in this first blank here? Does anybody want to take a guess which number would go in this first blank here? What do you think? 4 goes here, and what do you think is going to go here? 3. So we've got one conjecture that this is a 4 and this is a 3. Anybody want to agree with that or come up with something different? Are you second guessing yourself? You think it's a 4 and the 3? It's a pretty safe bet, right? I told you guys we were going to be making like a connection between the starting value, the growth, and then all these things. So yes, you're right. It is going to be a 4 and a 3. The question is which one goes where? Which one goes where? What do you guys think? Is it going to be 4 here and 3 here? Is it going to be 3 here and 4 here? Which one do you think? You think the 3 is going to go here and the 4 is going to go over here? All right. We seem like we're pretty evenly split. I'm just going to give you the answer here. The 3 is going to go here, and the 4 is going to go there. So when we're writing an equation, our growth is going to be the thing that's multiplying the x, that coefficient in front of the x. And our starting value will be the thing that's added on at the end. All right, last question on this page, and then I'm going to have you guys do the next problem on your own. What would figure 100 look like for pattern A? Describe it in words, and then how many tiles would there be in the 100th figure? So if I were going to take this thing out and draw figure 100, what would it look like? If we started at figure 0 and we started building our 100th figure, how many tiles are we going to end up adding on this side to get up to the 100th figure? We're going to add 100, right? You said that we were adding 1 tile on this side for each new figure. How many tiles are we going to end up adding over here? 200, right? Because 2 tiles, we're adding 2 tiles each time. We're doing that 100 times. So it says to describe in words what it would look like. You guys go ahead and describe in words what it would look like. I don't know how you want to describe that. I might say something like there are 4 tiles on the bottom, and on the left side there's 100 tiles, and on the right side there's 200 tiles. However you want to put that into words. I'm not going to write that. I'll let you guys think about it. But I do want us, once you get that in words, to answer the final question, how many tiles would there be in the 100th figure? And if you come up with an answer to that, I'm going to challenge you to tell me 2 different ways that I could come up with that number. So I'm going to give you guys a minute to think about this. See if you can figure out for me how many tiles are there going to be in the 100th figure. And again, if you can come up with an answer that you're fairly certain of, I want you to see if you can find a different way of explaining it. I'm going to ask you to explain your number to me. See if you can come up with 2 different ways to explain it. Feel free to chat with the folks sitting around you too. Okay, so can someone explain to me, well, first of all, what number we come up with? How many tiles? We came up with 304. Can I get someone from this group over here to explain? You guys had a good explanation for this one. The way that you originally told me, yeah. Actually, can I get Michael? Do you mind? You did a really good job when I came around. Sorry to put you on the spot. Yeah, so there was 100 on the left over here. It would go much further than that, but there's 100 going up that way. And then there's another 200 on the right. 100 and 200 makes 300, and then you got those 4 original ones on the bottom. So you guys see where we're getting the 304 from this way? If I wanted to say that, I could say we started with 4, and then we're going to put 100 on the left, and we're going to put 200 on the right, and that gives me 304. Did anybody come up with another way of describing this? Perhaps a way using the table or the equation? What did you come up with? That's fantastic. Did you guys miss that? You totally missed that. That was super important. Hey, pay attention, okay? Especially when your classmates are saying important stuff. Thank you. That was awesome. That was awesome. So you went from the equation. If we look at this equation, the equation y equals 3x plus 4, this equation allows us to predict how many tiles there are for any figure number. So what Winter said is, why don't we just take the equation and we'll just put 100 in place of that x there. And then we just have to work out what this is. That's 3 times 100. That's 300 plus 4. That gives us that 304 also. Anybody come up with a way to use the table to come up with that number, 304? This one is maybe a little bit not as clear as these two, but here's how I would look at the table. I'd say we're starting with 4, and every time I go up, I add another 3. So I'm going to add 3, but I'm going to do that 100 times. So I'm going to start with 4, and I'm going to add 3 times 100, and that would also get me 304. So that's how we could kind of think through it with the table. All right, remember our goals for today is we want to be making connections between a situation which involves a starting value and a growth value. We want to be able to turn that into a table. We want to be able to turn that into an equation. Are we feeling pretty good so far? Let's see how we do on our own. So if you'll flip the page over, 2-2 is pretty much the same thing. I want you to go ahead and figure out what's the pattern. Find your growth and your starting value. Turn that into a table and an equation. Don't forget to write your equation, y equals something x plus something. And if you finish with that, feel free to move on to 2-3 down at the bottom. I'll be coming around to answer questions here in just a moment. Feel free to ask the folks sitting near you as well. We'll come back together in about 5 or 6 minutes to talk about this and wrap up. So I found it helpful for me to color in the new tiles. So from here to here, I added these 2. From here to here, I added these 2. From here to here, I added these 2. And then I was able to go back and figure out that these were the 2 new tiles. So we must have just started with these top 3. So as I was walking around, I saw most of us had a starting value of 3 and a growth of plus 2. And then when I was watching, I watched a few of you make the table, and you were not counting tiles. You were just using that starting value and that growth to fill out the table. Did most of you do it that way instead of going back up and counting tiles? You could do it, Did anybody count the number of tiles in figure 4 just to make sure that this was the right number? Did anybody do a quick check just to see if their pattern was working? I did, and I found that I made a mistake, and that's why you'll see there's some whiteout tape on here. So remember, if you are representing an actual situation, it's always good every now and then to take the numbers that you came up with and make sure they work. I went through and counted, and I did have 11 here, so that made me feel pretty confident. Were you guys able to write this equation? Were you able to get the 2 and the 3 in the right place? Okay. All right, let's look at the last one together. Some of you have already started on this one. This one's a little bit more advanced. So our goal was to be able to go from a situation to a table and from a table to an equation, and I feel like you guys are feeling pretty confident about that. If you can do that, let's stretch ourselves a little further and see if we can go backwards. So this time around, I'm giving you an equation, and we're going to use it to fill out the table. We don't even have the pattern in front of us. But let's see if we can figure out this information from the equation. So when you look at that equation, I'm hoping that you're zeroing in on 2 important numbers, this 3 and this 1. One of those things is the starting value, and one of them is the growth. Which of those numbers is the starting value, the 3 or the 1? Yeah, the 1 is the starting value. Yep, so our starting value is always going to be in that position, the constant value, the thing that is not being multiplied by x. And that number that's a coefficient on the x is going to be our growth. So we can go ahead and answer part B right now because we know that our growth is 3. We know our starting value is 1. If we know the growth and starting value, then it's pretty easy to fill out the table, right? When I fill out the table, I'm going to put the starting value where in the table? It's always going to go with 0. So the starting value is going to go there, and then I'm just going to use my growth pattern to fill out the rest of the table. I'm just adding 3 each time. So go ahead and fill out the rest of your table. Start with 1 and just keep adding 3 each time. 1 plus 3 is 4, plus 3 is 7, plus 3 is 10. All right, these last 2 questions are the key questions for today. So I want everybody to have a read through these and to answer them in the best way possible for you. You can answer them in words, or you can draw something. It's entirely up to you. But I want you to think about going forward, if I gave you a table and I asked you to look at that table and figure out what's my growth and what's my starting value, where are you going to look in the table to identify the growth and the starting value? Where do you look in the table to identify the growth and the starting value? And then part D, same question, but this time equation. If I give you an equation, like we did in this problem, where do you see the growth and where do you look to find the starting value? I'm not going to write my answers up here. I'm more interested in you writing down what you know and understand at this point. Where do you find the growth and where do you find the starting value? Once you have those finished, I'll be around to hand you the assignment. You can get started, and please ask any questions over anything that you didn't understand today or want some more explanation on.